Hi, my name is Markéta Kubánková, and I'm a researcher at the Max Planck Institute for the Science of Light in Germany. I work at the interface of physics, medicine, biology, and engineering, and I'm interested in the physical properties of cells, the building blocks of life. In 1989, I was a baby. I was born in Prague in the Soviet bloc, and so the fall of the Iron Curtain completely changed the course of my life. Today there are no barriers, so I could follow my scientific curiosity to do research in London and now in Germany. I wanted to be a ballerina, but luckily, at the age of 8, I got my first microscope, and that paved the way to science. My research breaks the walls of cell-based diagnostics. Today, observing cells is essential for making a diagnosis. You go to the doctor, they take your blood or urine. A surgeon takes a tissue biopsy. A gynecologist might do a pap smear. What all of these have in common is that the cells contained in these samples are analyzed. Cells are like tiny messengers carrying rich information about your body. Looking at them will help to define the diagnosis. But sometimes looking is not enough. To illustrate, let me take you to the supermarket. You want to buy avocados. But how do you know which one is ripe? Looking at it is not enough. You would feel it. You gather a lot of information about the world around you through your tactile sense. Surprisingly, so far, this valuable information was missing from cell-based diagnostics. But how do you feel a cell? How do you measure the stiffness of something so small? Here is our approach. A cell is pushed through a narrow channel where it deforms. If it is stiff, it deforms less. If it is soft, it deforms more. We already know that the physical properties of cells are a marker of diseases such as cancer. But until now, we could only measure about 100 cells per hour, not enough for diagnostics. This is what we have changed. With the new technology, I can measure up to 1,000 cells per second. So in one day, I can measure what could previously be done in 100 years. Finally, I can use the technology for diagnostics. And thanks to the boom of artificial intelligence, I now have the powerful tools to deal with such big data sets. I believe that studying the physical properties of cells will help us understand the human body and diseases. I see potential to revolutionize cell-based diagnostics. And I hope that one day you will go to the doctor and he will measure the physical properties of your cells. That will help him find out what's happening in your body and what the best course of treatment is. We now know that the physical properties of cells, such as cell stiffness, change during diseases. But I still wonder why that is. Can we manipulate these properties to fight diseases more efficiently?